I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss the topic on General Theory of Transmission Lines for the course Transmission Lines and Antennas. So first of all, we should know about the need for line parameters. The line parameters are very important to design a transmission line and also to understand the properties of a transmission line. So there are four primary transmission line parameters. They are resistance denoted by R, capacitance denoted by C, inductance denoted by L, and conductance denoted by G. And the first parameter resistance, and this parameter of any transmission line rely on the cross sectional area of the conducting material. These parameters are distributed parameter networks. That means the parameters are distributed uniformly along the entire length of the transmission line. It is represented by R and its unit is ohm per unit length of the line. And the resistance R is given by the formula R is equal to rho into L by A. Here rho represents the conductivity of the conducting material, L is the length of the transmission line, and A is the cross sectional area of the line. And the next is the capacitance. The parameter capacitance is represented by the letter C, and we know that a transmission line is composed of two parallel conducting wires separated by a dielectric material. So it behaves as a parallel plate capacitor, thus it has some capacitance which is also distributed entirely over the length. So and also uniformly distributed. It is measured in farads per unit length of the transmission line. And activity. So the third parameter is inductance. When current flows through a conductor of a transmission line, it generates a magnetic field which is perpendicular to the direction of the electric field. As the magnetic field varies, electromagnetic flux gets generated in the line. So this EMF now flows in opposite direction with the current flowing through the device, and this rise to the phenomena of inductance. And the inductance value depends on the current flowing through the conductor, and it is represented by the letter L, and its unit is Henry per unit length of the conductor. And the last primary parameter of a transmission line is a conductor. The two parallel conductors are separated by a dielectric medium, but it is not a perfect insulator. So due to which some current also flow through the dielectric. This current is called leakage current, and it is responsible for leakage conductance through the transmission line. It is basically present between the conducting wires, and it is represented by G. Its unit is mho per unit length of the conductor. The transmission line parameters related to other parameters is transmission line series impedance is given by Z, and it is equal to R plus j omega L, and its unit is ohms per unit length of the line. Next is the admittance. Transmission line shunt admittance is given by Y is equal to G plus j omega C. So this the unit is mhos per unit length of the line, and here G is the conductance, C is the capacitance, and the angular frequency omega is given by 2 pi f. Characteristic impedance of the transmission line given by Z0 is equal to square root of Z by Y. Z is series impedance, Y is shunt admittance. And propagation constant of a transmission line gamma is equal to alpha plus j beta is equal to root of Z into Y. Here alpha is the attenuation constant, and it is Nepers per unit length of the line, and beta is the phase constant, it is the radians per unit length of the line. So z equal to r plus j omega l and y is equal to g plus j omega c. And multiplying this characteristic impedance and propagation constant, it gives gamma into z naught is equal to root of z into y multiplied by root of z by y. So here y get cancelled, so root of z squared gives z. We know that z is equal to r plus j omega l. And now dividing the characteristic, dividing the propagation constant by the characteristic impedance, gamma by z naught gives root of z into y divided by root of z by y. We get the answer is y. It is g plus j omega c. And this gamma and this z naught are also known as secondary constants of the transmission line. So far we have discussed the four parameters of a transmission line represented as R, L, C, G, where R is the resistance measured in ohms per unit length of the line, L is the inductance measured in henries per unit length of the transmission line, C is the capacitance measured in farads per unit length of the line, G is the conductance measured in mhos per unit length of the line. And all these parameters are used to find the properties of the transmission line, and these are called primary constant of a transmission line. And also we have secondary constant of a transmission line. One is the characteristic impedance z0 and another one is propagation constant gamma of a transmission line. So now rectangular to polar conversion example. For example, in the first sum the rectangular coordinate is 4 plus 3j. So by converting this we get the polar form. 5 angle is 36.87 degrees. In transmission line, most of the parameter involves the complex numbers, so we should know the conversion from rectangular to polar coordinates. And also addition subtraction. So by adding two quantities of a complex number, so the real numbers added directly and the imaginary number added directly. And the multiplication division of two polar coordinates, the real part, that is 360 degree, the magnitude part is multiplied directly, and during multiplication the angle is directly added, it is not multiplied, the angle must be added. And during the division of two polar coordinates, the division is done directly on the magnitude, and for the angle we should subtract the numerator angle minus denominator angle and divided by taking square root of the angle we have to divide by 2. And the example problem, the characteristic impedance of a uniform transmission line is 2000 ohms at a frequency of 1 kilohertz. At this frequency the propagation constant was found to be 0.054 magnitude and angle 60 degrees. So determine the values of the lines RL, CG. And we know Z0 is Z0 formula, it is Z0, gamma into Z0 is R plus j omega L, omega is 2 pi f. In the problem f is given as 1000, so we are getting the omega angular frequency value is 6280, and Z0 is given in the problem, it is 2000 ohms, and R plus j omega L is gamma into Z0, and it is getting as 54 plus j 93.53 ohms. And here L is obtained from the formula of omega L, and G plus j omega C is obtained by using the characteristic impedance. The numerator is the propagation constant by the characteristic impedance, so its value is 27 into 10 power minus 6, 60 degrees. And by converting this we can get the G and C value. So equating real and imaginary parts, we get G value as 13.5 into 10 power minus 6 moles per kilometer. C is 3.723 millifarads per kilometer. So now the assessment, which of the following parameter is not a primary parameter, and we know by inspecting all these parameter, and not primary parameter is the attenuation constant, and the primary parameter associated with the magnetic flux linkages, here it is an inductance. The primary parameters associated with the electric charges is the capacitance C. And the leakage current in the transmission line is referred as the conductance. And the lines having RLC distributed along this circuit are called distributed networks. Thank you.